Now, in reaching a decision in statistics, it is dependent on the data that we gather. If the data is not representative of the sample, well, then you're probably going to make an error for sure. But even without making sure that if you do make sure that it is representative, it could still lead you to an error. And there are two types of errors that we talk about in from a statistics point of view. Okay, certainly there could be, user error, experimentation error, self-reporting error. Those are kind of outside of our lens right now. Okay, it's just these are the possible errors that could have been made from any statistics that we have done. And so there's type 1 and type 2 errors. Okay, and so type 1 error is that the decision of the test was to reject the null hypothesis, when in reality the null hypothesis is true. So what just to kind of summarize this, decision was to reject the null hypothesis. So we would reject the null hypothesis. But in reality, the truth, even though we don't know it, would be that the null is true. Okay, so can you kind of see how this is an error? Because we would say, okay, throw away the null hypothesis. It's not true based on the data that we gathered. And so we would believe, or we would favor the alternate. But in reality, it's actually the null hypothesis that's true. So there's a mismatch, okay? Because we believe we lean towards the alternative hypothesis, but in reality the null is true. A type 2 is exactly the reverse. Okay, so the decision is to fail to reject the null. So we would favor the null over the alternative, I'll say. Okay, we don't prove it by any means, but then in reality, the alternative is true. Okay, so again, there's that mismatch of we think based on our statistical findings that we believe the alternative or the alternative is not true, and so we think the null is the better option, and when in reality the alternative is the better option. Okay, and so consequently with each of these types of errors there is an associated probability that they could happen, or a chance that they could happen, and these we quantify as alpha and beta respectively. So alpha for type 1, beta for type 2. Wait, didn't we see one of these symbols before? Alpha, that was when we were using our comparisons, right? P is less than alpha, or P is greater than alpha, or P is less than or equal to alpha, right? So this is the same as the significance level. Okay, so just be on the lookout for that. When you specify a significance level, when you're saying, P is less than 0.05 or whatever, that's actually saying what the chance of a type 1 error is. And so we just want to be on the lookout for that and make that connection. Okay, beta, the only thing that we really use beta for, there's a concept called power of a test, and that is 1 minus beta. We don't get into this concept in this course, but you could research it and or continue on to biostatistics, where you will interact with this concept of power a little bit more. But nevertheless, this video is talking about the errors that could have been made from statistical analysis. Okay, and we have type 1, type 2. And so in context, we have to be aware that, okay, if we made this decision, this is the type of error that could have happened, and then think through, okay, if this was an error, what are the consequences? Does somebody, lose their life, or do they just, they're out a few $100s? Well, okay, I think a few $100s is maybe a better consequence than losing their life. But so in the next video we'll go through an example where we summarize the results, make a decision, and then investigate what's the error that could have occurred and what are the consequences of it.